The biggest advantage of an ultra short throw projector over a standard projector is the ability to use specialized ALR and CLR projection screens that block out ambient light, allowing you to watch your projector during the day with the blinds open and the lights on. But the big question is whether a $400 CLR screen performs just as well as a $1,400 one. So to answer that, I've gathered 8 popular screens from all different price ranges to see exactly what the difference is. In this video, we'll test their construction quality, screen gain, black floor, ambient light rejection from different light sources, microscopic structure, and finally we'll do some side-by-side testing with both a standard brightness projector and an abnormally bright one. After that, for $686 plus shipping is this 100-inch lenticular CLR screen from Nothing Projector. The Nothing Projector frame was identical to the WeMax frame, which as I mentioned before was both sturdy and easy to assemble. Just like the WeMax, the screen material is installed and tensioned using fiberglass tension rods and springs that attach to the aluminum frame. In addition to a convenient spring design that has a separate loop for a spring puller, the frame also includes 2 different slots for attaching the spring, which allows you to apply more tension if needed. Just like the WeMax and Akia screens, the instructions for tensioning had a clear spring attachment order, which allowed me to easily get the screen tensioned without any wrinkles or ripples. The smell from the Nothing Projector screen was very mild compared to the Akia screen. The construction of the Nothing Projector screen took me approximately 1.5 hours. $1,479 plus shipping is the Nothing Projector 100-inch fluorizing CLR screen. Like the VividStorm, the Nothing Projector screen is a lenticular CLR design and uses articulating tension arms on the back of the screen combined with tab tensioning on the outsides to create a rolling screen without wrinkles or creases. The Nothing Projector fluorizing screen is 2 inches wider than the VividStorm for a total size of 98 by 6.25 by 4.5 inches, and the Nothing Projector screen also comes with a remote in addition to having on-unit controls. Screen gain is a measurement of how much of the projector's light gets reflected back at the viewer, and it's measured from a 0-degree viewing angle at the brightest portion of the screen. Since higher gain screens reflect more projected light to your eyes, they produce a brighter overall image, but using a lower gain screen will improve contrast and black levels of your projector. In general, you should pair a high lumen projector with a low gain screen and a low lumen projector with a high gain screen to get the most vivid image, best contrast, and best black levels. To get a baseline value for gain, I used a 1.0 gain screen material from VividStorm combined with a pure white image projected from the 4-movie theater ultra short throw projector. Measured using my lux meter with a directional attachment, the 1.0 gain screen gave a value of 19.4 lux at a distance of 1 meter. I repeated these exact same steps for each screen material and the results were pretty odd in that they didn't closely correspond with the values listed on their manufacturer websites. I found that the brightest screen by far was the 4-movie Fresnel screen, which I measured at 1.54 gain compared to its listed gain of 1.0. The Elite CLR3 material is supposed to have a gain of 0.8 versus the 0.9 on the CLR2, but I found that the CLR3 had a significantly brighter image and I measured the gain at 0.97 while the CLR2 had a measured gain of 0.8. Of the screens that listed a 0.6 gain, the Nothing Projector screen was the brightest with a measured gain of 0.8, followed by the VividStorm at 0.74, and then the WeMax at 0.69. The replacement Spectre screen was listed at 0.5 gain, but I found that it was about the same as the other screens at 0.77. Another important measurement is the black floor, which is how much light gets reflected back when the projector shines an all-black screen. Generally speaking, the higher the gain, the higher the black floor will be, meaning blacks won't be as black. Using the same testing methodology, but projecting a black screen instead of a white screen, I found that the black floor of the white calibrating screen was the highest at 0.06 lux, followed by the Akia at 0.05 lux. Then it was the Nothing fluorizing screen at 0.04 lux, then the Elite, VividStorm, and WeMax at 0.03, then the Nothing Projector fixed frame and 4-movie Fresnel were at 0.02 lux, and the lowest black floor was the Spectre Vantage at 0.01. Gain and black floor are common measurements for any projector screen, but the main selling point of these screens specifically is their ability to exclude ambient light, specifically from ceiling light sources. So to test that ability, I used 2 banks of diffused LED lighting, one bank at a 45-degree angle from the center of the screen and another at a 15-degree angle. And again, I calibrated the measurement using that 1.0 gain non-ALR screen sample. Starting with that 15-degree angle light, which would be similar to having ceiling lighting over your couch, the Elite CLR3 screen material rejected 49% of that ambient light. Then it was the Akia CLR2 with 51%. The Spectra, VividStorm, and Nothing Projector fluorizing all rejected 60% of ambient light from 15 degrees. The Nothing Projector fixed frame rejected 62%. After that, the least expensive screen, the WiMAX, rejected 64%, and then the highest light rejection value came from the 4-movie Fresnel screen at 70%. Moving on to a much steeper 45-degree ambient light angle, the pure CLR screens improved significantly, with the Akia CLR2 screen performing the worst at 62% rejection, then the Elite CLR3 at 70%, the WiMAX at 72%, the 4-movie at 76%, the Spectre at 78%, and then the Vivid Storm, Nothing Projector Fluorizing Screen, and Nothing Projector Fixed Frame Screen all had 80% rejection of light at a 45-degree angle. So from a pure light performance standpoint, we would expect the best performing screen to be the 4-movie Fresnel screen, which had the highest gain, lowest black floor, best ambient light rejection at 15 degrees, and was only 4% away from the best light rejection at 45 degrees. But the problem with Fresnel screens is that they're designed for a very narrow viewing angle of about 45 to 50 degrees, and off-center viewing will result in hotspots and dim areas that you won't get with a lenticular CLR screen. The highest performing lenticular screen on paper is the Nothing Projector screen, with a gain of 0.8, a black floor of 0.2 lumens, 62% rejection of 15-degree ambient light, and 80% rejection of 45-degree ceiling light. However, it's not all about light performance, and the ability to clearly resolve every pixel of an image is a reason I often see cited as a justification for a higher priced screen. Using a microscope, I examined each screen structure at 6 different points to get a representative image of the microscopic structure. The first thing to notice is that all the screens, regardless of the price, have the same number of sawtooth ridges. I counted 36 ridges per centimeter, so for a 100-inch diagonal screen, which is 49 inches or 124.5 centimeters tall, there would be 4,482 horizontal ridges, which is more than sufficient for the 2,160 horizontal pixels in a 4K screen, and even enough for the 4,320 horizontal pixels of an 8K screen. However, looking at their microscopic structure, there definitely does seem to be a correlation between price and the uniformity of the sawtooth structure. The cheapest screen from WiMAX looks fuzzy and deformed, while the Spectre has straight, rigid lines that could theoretically help it reproduce images more accurately. I also thought the variation in sawtooth pitch and the ratio of dark to light areas was interesting, but ultimately I couldn't find any correlation between that and my light performance data. Missing from this figure are the Akia CLR2 screens and the 4-movie Fresnel screens, which look completely different under a microscope due to their reflective coatings. But you can still get a feeling for how the CLR2 screen has the same horizontal lenticular pattern versus the 4-movie that has its varying concentric circles based on where I place the microscope. Alright, I love quantitative data more than anyone I know, but ultimately these numbers don't mean anything unless they translate to a better viewing experience. So to test that, I set up each projector side by side and projected a 100-inch image split between the two screens. To be able to more easily compare the screens, I edited the Dolby Atmos Nature's Fury test video to split it down the middle, with one side as a mirror image of the other, meaning that light, colors, and contrast will be right next to each other on both screens. I tested in 15-degree ambient light, 45-degree ambient light, and total darkness, and I ran each of the tests with the 2 best performing ultra short throw projectors from my 2022 showdown. The 4-movie theater, which is somewhere in the ballpark of 2,200 ANSI lumens, and the AWOL LTV 3500, which is somewhere around 3,300 ANSI lumens based on my personal testing. On 2, we've got the $450 WiMAX on the left and the $696 Nothing Projector screen on the right. And the ambient light black floor difference was even more severe than it was in the previous round, this time with the Nothing Projector screen with the higher contrast and better black levels in almost all conditions. For the 45-degree ambient light test and the 0 ambient light test, the Nothing Projector screen had blacker blacks and whiter whites. But in the 15-degree ambient light test, the WiMAX actually had a better black floor due to the fact that it was the lowest gain projector screen that I tested. Unfortunately, this also meant that its overall luminance was lower, which was more apparent using the 4-movie theater than it was with the super bright AWOL. Off-axis performance was equal between the two, and both offer the super wide viewing angles that lenticular CLR screens are known for. If your room has more diffuse ambient light and your projector is sufficiently bright, then the WiMAX screen might be a good choice. But in most situations, the Nothing Projector screen performed better, so it's going to move on to the next round. And this next round is a little bit tricky because it should be the Nothing Projector screen on the right versus the 4-movie Fresnel screen on the left. But the design of this test makes that impossible since the Fresnel screen blocks out any light that doesn't come from the bottom middle of the screen. So for this round, I tested each screen individually and then I cut and flipped the images in Adobe Premiere. And with the 4-movie screen set up properly, it significantly outperformed the Nothing Projector screen in both 15-degree diffuse light and the 0 ambient light test. And in the 45-degree ambient light test, the results were confusing. The Nothing projector clearly has a better black level and rejects more ambient light, but you can see that the lenticular design also has a noticeable gradient of reflected light, with the bottom of the screen having much better black levels, while the 4Movie screen looks more gray, but the black levels are uniform throughout the whole screen. So in most conditions, the 4Movie screen was significantly better as long as you're watching within a 45-degree cone. But off-axis, the 4Movie Fresnel screen was significantly worse. So I'm going to move the Nothing projector screen on so I can compare lenticular screens to lenticular screens, but I'm pretty convinced that Fresnel screens are the future of UST projector screens as long as extreme viewing angles aren't important in your space. So that means that on the left we've got the $696 Nothing projector screen, and on the right is the $1,299 Spectra Vantage. And with all the lights off, I could barely tell any difference between them, except maybe slightly higher color saturation on the Spectra and very slightly more contrast. But I'd mostly call it a tie. However, in the diffuse 15-degree ambient light, the black levels on the Spectra were noticeably better without any corresponding loss in luminance. And I even think that the white levels might have been slightly whiter on the Spectra as seen here. With the 45-degree light source, the outcome was the same, with the Spectra screen achieving slightly higher contrast due to its lower black floor, and off-axis both the screens performed well as far as image uniformity, but the Spectra had a more noticeable reduction in brightness. So overall, I do think that the Spectra screen has a slight edge over the Nothing projector screen in terms of black level and general performance, but whether it's $600 better is a decision you're ultimately going to need to make for yourself, and I think both screens are very good.